And what's even more important is this slide here. Now, in the quiz 5B, one of the questions gives you some statements and you have to decide if they are correct and rigorous. Rigorous means that it's really strictly correct, if it's just correct, if it gives you the right idea, or if it's wrong. So here are some statements here, and I'll try to explain to you why they're right or not. And it is a little nuanced, and it probably won't make a lot of sense to start off with, but you'll get there. Okay, what we can say we are 95% confident that the mean number of hours per week for students in the population lies between 3 and 10.1. So that was a confidence interval I worked out on this page here. So I've got 3, 10.1. By the way, you always round in your confidence intervals because the whole thing is an approximation. So to give lots of decimal places is just silly because it's implying a level of precision that doesn't exist. Okay, so that is a correct thing to say. It's also correct to say it's possible that the mean number of hours is less than 3 or greater than 10.1. So we could have missed it. How likely is it that we have missed it? 1 chance in 20, 5% chance that we have missed it. But we don't know. And so we can't say there's a 5% chance that we've missed it because we either have or we haven't. Probability only works in the future or in theory. Once something has happened, it doesn't have a probability anymore. It's because it's happened. The probability that it would happen is 1 because it did. So we have to be very careful. So we can't say there is a 95% probability that the true mean lies between 3 and 10.1 because it either does or it doesn't. Okay, so it's possible. We are fairly confident. There are words that people use for this. I don't use this very much, but 95% tends to be fairly confident. 99% is very confident. So we're fairly confident that the mean length of time is between 3 and 10.1. And this is probably the most rigorous one. This is the one that really explains what's going on. So if we were to take 100 samples of whatever number I took there and calculated the confidence intervals, we would expect about 95 of them to contain the true population mean. Okay, what we don't say that. We don't say that we're 95% confident that the mean number of hours per week in the sample. Okay, this is the bit that's wrong here. Okay, we never make confidence intervals about the sample because we know the mean for the sample is whatever the mean for the sample is, and we're using information from the sample to say things about the population. This is a key idea in statistics. We know about the sample, from that we're trying to say stuff about the population. And this is a very popular one, which I've thrown in lots of questions just to trick you. 95% of the students spent between 3 hours and 10.1 hours on Blackboard. That is not correct because we are talking here, the confidence interval is about the distribution of the means of samples of that size. So it's saying if we took lots and lots of samples of size, whatever number that is, this is the distribution, and 95% of, I don't even know if we could do that. No, it just doesn't work. If we wanted to say 95% of the students spent between whatever it is, we would need to have the population, we would need to find out the standard deviation, and we could then do 2 standard deviations either way, and that would give us what 95% of the students did. But it is not the same as a confidence interval, which is about what's happening to the means. Okay, I'll just give you some examples. You haven't got this in your notes because I just made it yesterday. So this is yesterday's samples. We got 2.9 and 3.4, so that gave us our confidence intervals here, minus 1.5, 1.6 and 7.3 and so on. Okay, so there's the population data. So what I've done is I've cheated. I've become God. I've said this is the population, I know the answer, so now we're going to check whether your confidence intervals worked or not. You can never do this in reality. This is a fudged example in order to illustrate a point. Okay, so I've got my population there, and then I took some more samples. Okay. And so here we've got 20 samples. If I could make the mouse work, would help a lot. No, mouse keeps disappearing. Mouse keeps doing very odd things. Okay, I'll use this one instead. Okay, so I've got all these samples here. And these were taken using random generation on the spreadsheet, but I could have done it by sitting all of those little yellow pieces on the floor and taking them one at a time and writing the numbers down and putting them back and so on. But it's much quicker to get the computer to do it. So I got the computer to take 20 samples. So there's 10 of them and 10 of them. Okay, so these are the 10 samples and these are the means. And what I might do is see if I can zoom. Ooh, look at that, I can zoom. Okay, so you can see, look, the mean of sample 11 was 2. The mean of sample 12 was 5.2, 5.25, 4.27, 3, 3.2, 2.4, 3.6. So you can see those means are quite spread out. Here's some more, 1.22, 1.8, 2.4, 3.8, and so on. Okay, so those are the means of 20 different samples I took. Okay, then I made 95% confidence intervals for them. How many would you expect out of the 20 to miss the population mean? Will any of them miss the population mean, do you think? Okay, 95%. 5% of them should miss the population mean. 5% of 20 is 1. So we would expect at least one of them to totally miss the population mean. And being God in this instance, we actually know what the population mean is. It is 3.66, blah, blah, blah. We'll say 3.7. So then I made this other picture here. These are the confidence intervals, and I'm sorry, Excel is dodgy to get to do things like this. I've had to sort of fiddle with it, so this is the best I can do. These things here are the confidence intervals for each of those 20 samples. And look at how different they are. Okay, the first sample, in fact, missed the mean. It's just this red line here is the population mean. You've got this one sample here, 12, has the most enormous confidence interval. This one here's got a teeny little one and it misses the mean. So in fact, more of them miss the mean than would be expected, and that's probably because 5 is such a ridiculously small sample to take. If I'd taken larger samples, these intervals would have been smaller, but you would still get 1 out of the 20 you would expect to miss the population mean. Okay, how do you know whether you've got one that's got the population mean or not? How do you know if yours is a good confidence interval or one that's wrong? Okay, and on that thought, I will have a little break and we'll come back in a minute and you can tell me. Can anyone tell me, how can you tell if your confidence interval is going to contain the mean or not? Well, it's a trick question because I'm just jumping to page 9 here. We'll come back about a minute. How often will our confidence interval miss the true population, and how will we know if it does? And basically, we don't know. That's the whole point. If we knew, it wouldn't be a confidence interval, it would be a surety interval, or a absolute, this is the answer interval. But because we don't know, so when we hit a confidence interval, there's a pretty good chance that we've got the range that includes the population mean, but there's also a not unsubstantial chance that we've missed it. Okay, and this is something that we go over in the video about confidence intervals, and I'll show you some illustrations in that. Okay, so we'll just come back to page 7 now, because we've done how to find the confidence interval of a mean using Excel, and now we're going to do a confidence interval for a proportion.